Hey everyone, on today's daily coding episode 22, day 22. So recently I've been doing some backtracking. I finished the I mostly finished the trees, easy and mediums. So I'm gonna look at now um, heap and priority queue. So I kind of learned how to implement those in Python on my free time yesterday, and I did last stone wait in my free time. So today I'm gonna try a medium heap priority queue problem. I have not looked at it yet. K closest points to origin. Um, okay, so you're given a 2D array points where points of I equals x I y I. So coordinates representing the coordinates of. Yep, you're also given integer k. Return the k closest points to the origin 0, 0. The distance between 2 points is defined as the Euclidean distance. Okay, so we're given points, so I think we want to have another function called get distance of. Okay, so my idea would be for each point, calculate its distance, and then like puts all points into a min heap. So the relationship between a point and its distance, I'm thinking maybe we could do as a dictionary perhaps. So we could say that the key equals a distance and the value equals the point itself. And then we can put each key into the min heap, and then when we pop from the min heap we can add the value. Okay, so let's say so this will be distance to point. All right, so 4 points in points, we want to get the distance of that point, and we want to put so that distance equals point. Okay, so this constructs the dictionary. A dictionary isn't iterable, right? So we should be able to. I'm curious when we call heapify on the dictionary, what will happen. Okay, so let me just print that, and then get distance will take. And it's always to the origin, right? Yeah, okay, because they could also pass this as a parameter, but it looks like it's just always the origin. So we'll take 1 point. So the point is a list. So we could say xi equals point. Yeah, so we'll say xi, yi. We could just say x and y equals points of 0 and point of 1, like that. And then we'll say the function. So let me just put that. All right, so it's always going to be 0. So what we can say is x squared plus y squared, because it's going to be minus 0 always. And then do we square the whole thing? So it's the difference squared plus the other difference squared. Okay, and then we just take the square root of that. Like this. And then we have distance like that. So I think we can just return that. Okay, let's see where we get an error here. Okay, so it's saying that a distance of 2 is 0, 2. That makes sense. And a distance of 2.8 is 2, 2. Right. Okay, so it looks like the dictionary is working. And then I wonder what happens if I say heap q dot heapify dist point, if that will work or not. Because I know it has to take an iterable, and you can iterate over a dictionary. So let's say before and after to visualize it. Okay, so it has to be a list. So instead what we can say is we will heapify the keys like that. Do I have to typecast it to a list? What if I do this? Okay. And then so we make the dictionary, and then we create min heap of distances, and then we want to return k closest points as what? As a nested list? Okay, so every point, so say result, and for I in range k, we want to heap q dot heap pop from distances. So this will give us the minimum distance, and then we want to append to result dist to point of min distance, like that. So this gives us the min distance, and then we use our dictionary to get the point. So this will give us a point of that min distance, and then this will give us, it will just add it to result. So if we print result, my output is, oh yeah, standard out. Okay, and then this 2 0 2 2. Okay, so if I return res like that, it's false. Okay, so I'm returning 2 0, and it says you can return them in any order, right? Yeah, okay. So I wonder if it has something to do with that these have the same distance. Yeah, that's definitely what it has to do with. Yeah, so if something has the same distance, I'm thinking a way we could do that is so we have like a distance of 2 as the key, and then our value would actually be a list of points that have that distance instead of, yeah, I think that would work. Is there a better way to do it? I think it's fine like this, because you could, I mean, you could do the point and then its distance, but you really want the minimum distance. Okay, so let's try it like this. Still not muted. Okay, so if so we'll say distance equals self dot get distance of points, if it's not in the dictionary, that will make an empty list, and then dist to point dist dot point. Okay, so I think it should be like this. So we'll get the distance of that point, and if the distance is not in the dictionary, we'll make an empty list, and if it is, we'll just append to that list. Yeah, so if it's not, we'll make the list and then append to it, and if it already exists, we'll just append to it and not make the list. Okay, so let's print just print what this looks like, and we'll look at test case 2. Yeah, so now we have several points for the same distance. Okay, so now that the only thing that's going to change is how we pop them. So instead of doing this, I think we can say while length of res is less than k, we will add to res. So and also here, actually, I just want to print I want to print distances and just make sure that the 2 is showing up twice. Okay, it's not. Wait. This is the wrong test case. Yeah, it's still not, though. Okay, so keys in a dictionary have to be unique. So we need to store somehow how many occurrences are of that distance. So maybe we can say for key in dist to point dot keys. We can say so we can just append that many elements. So we'll say distances dot append the key times, well, I guess we can say for I in range length of dist to point of key. Okay, so what this does is for every key, it'll add it this many times. So maybe instead I could say distances dot extend key times, I think it's fine how I have it. So for instance, if distance to point of key is length 1, it'll add it 1 time, but if it has 2 occurrences, it'll add it 2 times. Missing a colon. Okay, so now we see that we have 2, because when the length is 2, it'll add the key 2 times. Okay, so now this should, okay, so that seems to be working. And the runtime of this is basically just every point still. Well, yeah, it should be every point still, because this is just once per point, so it's still linear. Okay, so now this part. So min distance, and we want to append, we can just say while dist to point min distance. So while the list is empty and like, or while it's filled and the length is less than k, then we can say res.append I think maybe I could say list comprehension here. So we want to add okay, so we're not, point isn't being used right now, right? Yeah, I'll just say P. So for point in this array, so this is an array type. So for every point in that array, append the point to res if length of res is less than k. And we can just say for p in, I don't think we really need list comprehension there. So for p in dist to point min distance if length of res is less than k, then res.append p. So for every point, if it's less than, then add it. And then once we add it, if we still need more points to add, we'll get the next minimum distance. Okay, so let's see if this works. Okay, it does. Okay. There we go. And then the min heap of distances. So if we have a duplicate distance, then we'll add it n times into the array where n is the number of times that distance shows up. And then this part, so here we create the min heap of distances. So how could I word this? With copies. Yeah, like that. I feel like this is clunky. I don't know. I mean, I don't know like which is better. I mean, I guess this is fine because we don't store the array anywhere. I don't know. Okay. Yeah, so this works. And then the runtime is, let's see the runtime. I'm pretty sure it's linear. So this part goes through. So let's see. So points. Okay, points dot length must be greater than k, which makes sense, or equal to it. Okay, so it's 1,000. So this is linear. This is constant. This is constant. So this is all constant. So this part's just n. Heapify is n. For every key, so for every distance, which we don't really know, but it could be maximum 1,000. Then for every, I think this is just for every point, because we're looking at for every, yeah, because every point is only appearing once. So this is for every point. And then we just happen to do it by distances, but it's still every point. So this is linear. And then this part just like adds k times basically. And that's it. So this is also, so this is k, which is linear. So yeah, it looks like it's linear here. N log k. I think we're better than that. Oh, we'll extract heap popping. Wait. So, well, popping from the heap is constant actually. And I'm not adding to the heap. So I think we're good. I think this solution is actually linear. This is linear. Let's see what so min heap. So this part is equal to the number of points because appending is a constant operation. This is a constant operation. So this part is equal to points. This part is equal to however many. Yeah, this is equal to points as well, I believe. Well, heapifying a list of lists, I'm not really sure how that works. Maybe that's doing it. So basically, instead of doing the dictionary, the solution here just uses like a list that has the distance and the points. So I mean, I think that's makes maybe more sense. I thought about doing this or doing that. I just thought this would be easier, but it turns out with duplicates it's a little bit trickier. But it's basically the same thing. It's just a lot less code because you don't have to like do all this and this. While k is greater than 0. Oh. It doesn't matter. Same thing, really. Okay. Yeah, great. So today was day 22. There is 22 test cases as well. February 6th. Today is a Thursday. And yeah, so this is a fun heap Q problem, min heap. I actually am really happy I'm doing these because it feels very useful. A very useful data structure to learn. And I can't believe I didn't know more about them until now, but yeah, so that's today's episode, and I'll see everybody tomorrow.